Thanks for watching this screencast. In this screencast, our objective is learners will be able to write a linear function in standard form. Panthers in Learning Target 4, we're talking about linear functions, and to talk about linear functions, we need to discuss linear equations. A linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant. And then there are other qualifiers as well. Variables must not be multiplied together or appear in any denominator anywhere. There may be no power other than 1. And then the graph of a linear equation is always a line. We'll do a couple of examples, and we'll show a couple of non-examples as well. Here's an example of a linear equation. 4x plus 5y equals 10. That equation has only addition. There's no subtraction, but it would be okay if there was. The only multiplication that appears in the problem is between a variable and a constant, like 4 times x or 5 times y. So that's a great example. There's no power. You know, if I put an x squared on there all of a sudden, then we'd be talking about not a linear equation anymore. Let me undo that. Here's another example. And this really may be the form in which you're more used to looking at linear equations. Y equals, we'll do 3/4 x minus 100. Here you've got subtraction, which is okay. The only multiplication is between a constant and a variable. And you know, this is another example of just a linear equation here. Okay, there was no rule in it being linear that those constants multiplied by the variables have to be necessarily integers. We'll talk in a second about a special case of this line. Let's show some non-examples just to hopefully clarify the difference here. I hope you'll see right away why this is a problem. 3x plus y squared equals 6. The problem here would be the exponent, the power of y being a power other than 1. That's problematic. Here's another one that's a problem. Y equals 10 divided by x plus 3. And it doesn't matter the plus 3 or not there. 10 divided by x makes this not linear. Those are really common ways that we can change this to make it not linear. Here's one more. 5 plus 2 times x times y equals 0. This isn't linear because of the term right here, 2 times x times y. The multiplication can only be between one variable and one constant. The variables may not be multiplied together. Now, the goal of this screencast is to give you a chance to practice writing a linear equation in what we call standard form. And the standard form of a linear equation is the form a times x plus b times y equals c, where these three things here are all true, where a, b, and c are integers. Remember that integers are the set that includes both the whole numbers and their opposites. So if we wrote that set as a set, we would need to do something like this. What you can't have as a, b, or c is a decimal, a fraction that's not the same as a whole number, and if you did, we wouldn't write it as a fraction, we'd write it as that integer. So either a whole number or the opposite of a whole number. Also, the greatest common factor needs to be 1. If there's some common factor in each of those three numbers bigger than 1, you should divide both sides of the equation by whatever it takes to make those a, b, and c have a greatest common factor of 1. A must be positive. The solution there would be that you could simply multiply both sides of the equation by -1 and make a positive. And a and b are not both 0, and that's not something you'll run into so much. I hope you can see here pretty easily that if a were 0 and b were 0, the equation would just be 0 equals some constant, which if c was 0 would at least be true, but it wouldn't be a linear equation anymore because there are no variables involved. All right, let's work a couple examples, and then, as you probably know, we'll give you a chance to try one on your own. It says write the linear equation below in standard form. The equation is -3/10 x equals 8y minus 15. Now, one problem with this already not being in standard form is that we have a number in front of x that is not an integer, negative 3/10. But if I were to choose to multiply everything by something that would make this an integer, like maybe 10, I can see that I would be getting rid of the fraction problem, wouldn't I? Now I want to suggest something maybe even stronger that can get us even closer to our goal, and that is that I really can't have a negative in front of that first term in that x term. So maybe the thing that would be wise to do would be to multiply the whole equation on both sides by negative 10, and that's what I'm going to do. So remember that equation property of multiplication, that if you multiply the left side by negative 10, we'd better multiply the right side by negative 10 as well. And of course the distributive property is going to apply there, isn't it? So if I do this, what I'll have on the left side is simply 3 times x, 3x. If I multiply each of these terms by negative 10, I'm going to get negative 80y, and I'll get positive 150. Now the only thing that keeps me out of being in standard form here is that I don't have the x and the y terms on the same side. So let me take this term here and ship it over to the other side, and in doing so change its sign. How about 3x plus 80y equals 150? Now I should check quickly and see if there's anything that goes into those three constants, those three coefficients, other than 1. The only thing that goes into 3 other than 1 is 3. 3 does not divide into 80, and it doesn't divide into, well, it does divide into 150 actually, but since it can't divide into 80, these 3 as a set do not have a GCF greater than 1. We're finished. 3x plus 80y equals 150. Let's work a different one now. Write the linear equation below in a standard form. 2y equals 4x plus 8. There's a bunch of ways you could go about attacking this first. What I don't have is the x and the y terms on the same side of the equation. So I want to do something that's going to get the x and the y together. I'm going to choose to do this. I'm going to choose to take my 4x and move it to the left side of the equation, and in doing so change its sign. Negative 4x plus 2y equals only 8. And I've got x and y terms together on the left side of the equation. That's good. What is not good, at least one thing that's not good, is that I have a negative for my a term. So let me multiply everything here by negative 1. I want to change that. I want to make this positive 4x. It would be minus 2y now. And that would have to equal negative 8, wouldn't it? And what I should do now is check and see if there's anything other than 1 that goes into 4, 2, and 8. And what I hope you see right away is that there is. 2 goes into both. Or excuse me, goes into all 3. So let me divide everything on both sides of the equation by 2. That's the division property of equality. And write an answer like 2x minus 1y equals negative 4. And we've got that one as well. Okay, this is your chance to try it now. I'd like you to pause the video, give yourself a chance to try and solve this problem, and when you think you've got a handle on things, hit play and get some feedback. Okay, I think there are a lot of things you could do here that might be considered a good first move. One thing I noticed right away is that the x term, the coefficient of that term is not an integer. So this 2 is a problem. And maybe what I should do is I should deal with that problem. So I'll choose to deal with a 1/2. I'll multiply this whole side of the equation by 2. That'll get rid of my fraction here. But if I multiply the left side, of course, I need to do that on the right side as well. And I see another advantage because that's going to take care of this denominator as well. So we're going to get 2 times 1/2, which is 1. You don't need to write the 1 if it's 1x. You could just write x, but if you write 1x, that would be okay. 2 times negative 1y would be negative 2y. And then plus 4. Don't forget it's got to be by every term now. And that equals 7. And we're almost in standard form, but I don't have my number term entirely on the right side. So let me take this positive 4, ship it over to the other side of the equation and make it negative. How about x minus 2y? 7 minus 4 would be 3. X minus 2y equals 3. Sounds like a great place to stop. Thanks for watching.